Good morning, guys. This is Sumaiya. Welcome back to my YouTube channel. So, today in this video, we are going to learn how to calculate the UGR in the Dialux Evo. Before starting the video, I would like to thank all the subscribers and viewers who are constantly supporting me here. And I'm planning for a giveaway when I reach 500 subscribers. So, the giveaway will be something which will be very helpful in the Dialux Evo. So please, if you haven't subscribed to my channel, do subscribe so that you don't miss the giveaway. So now let's get started and learn about UGR. So here I have considered a small office waiting room, a simple furniture and some 3D models with some downlights, right? Now let's understand what is glare. Okay, glare is a visual sensation caused by excessive and uncontrolled brightness in the field of view. So this glare can be classified in two types, that is discomfort glare and the disability glare. Discomfort glare. So for an example, when it's a hot sunny day and you're going out for a walk, or when you're going out for a walk, you can't directly see the sun. Okay, that is very discomforting. It is very bright, right? So this kind of glare is called as discomfort glare, in which we humans by instinct we just look away when we see such a brighter object, right? This is the discomfort glare. Then what is the disability glare? Disability glare, here you don't see the source of the brightness directly, but instead you see the reflection of it. Okay, for example, you have your laptop and you're sitting and working, and the window is, or the light source is behind you. So what happens in this case is the light source or the sun rays from the window will fall on your laptop screen, and hence you will be unable to see the screen. This is the disability glare, where you don't directly look away, but it causes some kind of discomfort, right? So these are two types, disability and discomfort glare. Now coming to how we can measure this glare, the International Commission of Illumination, that is CIE, they made this UGR, Unified Glare Rating, as the unit of measurement for glare. So these are some of the basic things which we need to know as a lighting designer about glare, right? What is glare, types of glare, and how do we measure it? Later in this video, at the end, I'm going to mention some of the steps or some of the things which we can follow to reduce or to lower the level of glares. So for this project I have used cap 105 from Floss. Its wattage is of 17 watts and its wattage is of 17 watts and 1059 lumens. We will change it to LED and change the CCT to 5000 Kelvin since it's an office space, and make the CRI to 90 if really the light has 90 CRI, or you can keep it 80 as per the spec sheet. So we have done the basic settings. Okay, light is placed, reflection factors are set, textures are placed. So we will just directly look into placing the calculations for UGR. Now here in this space you have two areas in which basically a task is performed, or like here the people will be waiting, they'll be sitting here. So you need to know how much glare is coming on this area, and here on the reception reception, again the task is performed. So you need to know how much UGR we are getting here. So we will do two calculations. One is for the sitting area and other is for the reception area, right? The first step here is going to the calculation objects. Make sure you are in the plan view. Here you can directly place a calculation object or you can place a single point. So first let's see how to place a calculation object. Now here for the waiting area, I have already kept this 3D model of a lady sitting and waiting. So we will place this calculation object here itself. So you can go to the calculation objects, draw rectangular calculation objects, take the first point, second point and extend it, right? You can even move it by using this tool. Go to the 3D model and see the position it is on top of the ceiling. So you can bring it down manually or you can go to the positioning and make it say 0.85 meters, right? Because this lady is sitting here and her eye level is somewhere around 0.85 meters. Generally we calculate the UGR on eye level, either sitting or standing, because that's how we see the light, right? The second setting here is reducing the number of this calculation points. You can see the small dots here. If I zoom, okay, you can see number of dots. On this points itself, on this dots or points, the calculation will be taken. So I don't need so many calculation points. So what I will consider is, here I have 5 chairs, right? So I will consider 5 points here, and since it's only one row, so I will consider one row and 5 points. So I can change it here in settings for measurement grid. See here it's all in automatic. You can keep it in the quantity. So for x, in the number of x, I will just make one single line, and in the number of y, since I have 5 chairs, I will place 5 points because there will be 5 people sitting in this chairs. Press escape. So my basic settings have been completed. Click again on the calculation surface. You can name the calculation surface. Here it's calculation surface 2. You can make it as UGR for sitting area, right? Then come down to the calculation parameter. Here it's selected as perpendicular illuminance. Unselect this one and select for the UGR. Okay, this is the symbol for UGR and this is for glare rating. UGR and glare GR is different because UGR you calculate for the interior spaces and GR you calculate for the exterior spaces. So here, since it's an office interior waiting room, we have selected UGR. After selecting the UGR, you will see this tab open. Here some of the readings are present which you can change manually, like height offset, step width, viewing angles. Now what is this height offset? This one we will discuss it when we are doing the calculation point for the reception area. Height offset we'll discuss later. First we'll see what is step width, right? So the step width, when we generally see, we usually keep our head straight, okay, and we can see up to some degree of height by just looking up. Now this lady is sitting and she is saying straight, her head is straight. So this, so if I assume the normal line to be on x-axis here, so she can see up to some angle without lifting her head, okay, only by lifting her eyes. That angle is nothing but the step width. Now see another example of this man, okay. So he has slightly tilted his head up. So if I make the normal line here on x-axis and make an angle with the line where he is seeing, so here he is seeing up, so if I make one line here, so this angle is slightly larger than when you normally keep your head straight. So he is just lifting his head up so he can see for more angle, right? That is nothing but step width. So calculation objects, here step width will just keep 15 degrees itself. If someone is lifting their head up, okay, depending on that one you can change the step width. Say for this lady if it is 15, maybe for this man is lifting his head more, maybe it will be 45 or 50, right? Then what is this viewing angle? Here it's written 0 to 360 degree. So we'll go to the top view to understand this term. This lady is sitting here and she is facing this side. Since she is facing this side, she will be able to see the view of this scene. So she will be able to see the view from here to here, okay, unless she is rotating her head. We don't rotate our head to 0 to 360 degree, we just see it from 0 to 180 degree. That is the our viewing angle. So we will change this from 0 to 180 degree. Enter. So these are the basic settings you need to know. Once this is done, run the entire project. So the calculation is completed and you can see in the results overview it is showing me green color. It means I have achieved the standard value for the UGR. Now what is the standard value? Here it's showing me 12.2. Let's see what is the UGR. Let's see what is the minimum UGR we require. So your UGR rating can be from 13 to 25. If the UGR rating is more, it means the glare is more. Say if it is the common UGR 25, it is not comfortable. It means that you have much glare. If it is coming down to 22, you can feel the glare, but still you have that discomfortness. Okay, say that UGR is coming down again to 19. It's okay. It's still discomfort, but then it's still okay, not good. If you have UGR rating to be 16, then it is a good UGR value. And if it is 13 and below 13, it is an excellent lighting design with the low UGR and glare ratings. So your scale should be between 13 to 19. I would prefer you can keep it between 13 to 16 or lesser than 13 is really excellent. So I have got here 12.2, which means my results are good, right? So we will see the same how it is displaying me in the documentation. So we'll go to the documentation, select the calculation objects. So here is the calculation surface I have placed. Strongest glare at 30 degree, maximum glare I'm getting is at 12.2. Viewing sector 0 to 180 degree. Step width I explained it's 15 degree. Height of the calculation surface is 0.85. And these are those 5 calculation points. Let's zoom in. Okay, so here on the first chair I have 10, second chair 10. 12 is slightly more, it's 12. Next 10 and 10. So whichever glare you have more compared to the others, it will be shown in the bold letters. So this is how you calculate UGR by using the calculation surface. Let's see how we are going to do it with the calculation point, and let's learn about the term height offset. Okay, so we will cancel this calculation, and I will even cancel this calculation surface. Now we'll use the calculation point on the reception area. Since here I have two chairs, I will be needing a calculation surface itself. But here, since it's only one person here, I can place the calculation point. So let's first place the calculation point. Go to the calculation objects, select, and here you have calculation point. Click on place calculation object and zoom in and place it here. So my calculation point is up, so you can manually bring it down like this, or you can go to the positioning and set it. So normal maybe 1.5 or 1.6 meter for a standing eye level position. Yeah, here. Okay, so you have placed the point. This point is really very small, so be careful when you are selecting it. So my point is placed. Next, the calculation parameter. I have to unselect the horizontal illuminance and select for the unified glare rating. Step width, say, since he's looking up, I will increase it to maybe 45 or maybe 35. And viewing angle is from 0 to 180 degree. And this is done. Next, we'll place one calculation surface here. Go to draw rectangular calculation objects, select first point, second point, and extend it. Calculation for the calculation surface positioning. Since the man is sitting, I'll make it 0.85 meters, and settings for the grid quantity, it's only one row, so I will keep it as 1, and 2 people, so 2 points, right? If you want the position to increase, you can increase it, maybe 0.9 or maybe 1 for this case because it looks heighted on the eye level, right? Then go to the calculation parameters and select this one and select for the UGR. Say I have placed this calculation object at 1 meter, right? That is the eye level for this person. For this step width, I'll keep it as 15 degrees itself, viewing angles from 0 to 180 degree. And here we will check the results first by keeping this height offset as 0. Once we'll finish calculating it, again we will change it and see the calculation difference. So I have placed the calculation surface and the calculation points. Now run the entire project. So here you can see the calculation point which I placed near this man. So it is 10.2. Even when he is lifting his head up and looking up, still he has less glare because the fitting is nice. And the calculation surface 3, that is at the reception area, it's 10. So it's lesser than 10. So I have a nice excellent glare rating. You can check the same in the documentation. Now we'll close this one. Here this person is sitting now. Suppose this person is standing, right? Now this person is standing, right? I have the calculation surface already placed here. I don't want to change any settings. This was the calculation surface I placed when this person was sitting. Now I want the same calculation to be done when he is standing. The simple setting here you can do is height offset. You remember this is at the position of 1 meter, right? Without changing it or lifting it up, in the calculation parameters, what you can do is just increase the height offset, right? Here it is at 1 meter, say he is standing now, and assume that his eye level now will be at 1.6 meters, right? So already this calculation surface is at 1 meter, so I need to increase 0.6 meters to get an eye level of 1.6 meters, right? So I'm just doing the setting on the height tab set as 0.6 meters. Okay, this calculation surface will remain on the same 1 meter if you see it, but the calculation will be calculated at 1.6. I will show you how. Just run the entire project calculation. So here on the calculation surface, still I have the glare lesser than 10. We'll go to the documentation and check this out. Here the calculation surface 3. So this is the calculation point and this is the calculation surface for the 2 points which are placed at the reception area, and here you can see the height 1.6 meters. Though my calculation surface was at the position of 1 meter, I gave it an offset of 0.6 meters. That is why the total height where my calculation has been taken place is 1.6 meters. So this is about the height offset. I hope I have explained all the points required for UGR calculation, that is the height offset, step width and viewing angles, right? Even the documentation. Then as a lighting designers, we need to know how to reduce this glare or have a UGR rating from 11 to 16 or below 11. So these are some of the steps you can consider for reducing the glare. So this is it guys in this video. I hope you found this video helpful and I think you can do the UGR calculations. And please do subscribe to my channel because I have a giveaway when I reach 500 subscribers. Stay tuned to explore more and dialogues with me. Thank you.